Okay, so velocity time graph. We can also have a situation of uniform velocity motion. So here we won't call it uniform velocity, but uniform accelerated motion. When the body speed, okay, changes within equal intervals, within equal time, uniform accelerated motion.
So how I think the graph because in this with my time graph, the y-axis was s over m, and then the
S/M.
and then the x was speed as s, and then velocity is m meters per second.
Right.
So how are you going to write it?
Right.
On the y-axis?
So this is velocity time graph. And when you have a situation where the velocity of the body occurs within equal time interval. So V meter per second, T 0, 1, maybe 5, 2, 10, 3, 15, 4, 20. When you plot, you have this. When you plot, you have this. And when you find the slope by picking any 2 points, changing V, changing T, the slope would give you change in V and change in T, which is equal to acceleration of a body. So if you have, and this motion is what we call as uniform accelerated motion. Because when you pick any 2 points, the acceleration is the same along the straight line.
So when you find it, it is y2 minus y1.
Yeah.
Is it necessary to make y2 greater?
Greater.
Yes.
Y2 will certainly be greater as time goes by. And yeah, time 0, maybe 1, 2, 3, 4, 5. So as time goes on, if you trace this to this, okay, and this will be y2. This is if you pick any 2 points, this is y1, and this is y2. So y2 will be greater. That's why the body would accelerate because the velocity will be what? Increasing. All right. The velocity will be increasing. All right. So for uniform accelerated motion,
Let's take y2 to be 10 and y1 to be 5.
so let's put in our values. So if you are looking for this, the slope, this slope will be equal to delta V. Okay, you already have it here. So your y2 is 20 minus y1, which is 5 over change in time 4 minus 1. So we have 15 on 3, which is 5 meter per second squared.
Now, can you make 5 come at the base of y? Try to be 5 minus 4.
we are developing something, so take your time. Okay, they don't swap. We are considering a situation where the body's velocity increases within equal intervals with time. So we just as we saw for velocity displacement time, we also consider a situation where the velocity is what? Decreasing. Okay. All right. So the slope of a velocity time graph is equal to the acceleration of the body. And here the acceleration is positive because the velocity is an increasing one. Okay. Mm.
If you subtract 5 and 20 from 5, you minus 15. And if you subtract
If you subtract what?
20 from
Mhm.
5, negative 15.
Mhm.
If you subtract 4
Mhm.
from 1, negative 5.
Mhm.
And you still take the same.
We get what?
The same answer because negative.
Keep quiet and listen to the A. So this is uniform. A situation where the velocity is what? The velocity is what? Increasing within equal intervals and then time. Let's look at a situation where the velocity is decreasing within equal intervals. So this is increasing velocity. Let's look at decreasing velocity with time. But the decrease is within equal intervals, right? If you draw a data for the velocity and time, velocity, meter per second. Okay, 0, 1, 2, 3, 4, 5. By this time, we have the velocity decreasing with time. Okay, so 20, 15, 10, 5, 0. The let's end at 4. Okay, so the velocity is decreasing within equal intervals. When you plot such a graph, okay, this is what you have. You also have this. Okay, and here, because the angle that the graph makes with the time axis is constant, we say that the acceleration of the body, the slope, which is the acceleration, is also what? Constant. Are you okay? Hence, or constant or uniform. Hence, uniform accelerated motion. All right. Over here too, because the angle, the time axis also makes with the slope is also constant. This is also a constant or a uniform, but we have a decreasing speed. So the body's speed is decreasing. Decelerated motion. So this is also known as known as a uniform decelerated motion. Why decelerated? Because the velocity decreases within equal intervals with time.
So to determine whether it's uniform acceleration or deceleration, you can either use the angle or you can find the slope.
Yes, you can find the slope, but all that you need to also understand is that In acceleration, acceleration has to do with increasing speed or what? Velocity. Deceleration has to do with decreasing speed or what? Velocity. That's all. Is that okay? You are not writing it. When we talk of acceleration, it has to do with increasing speed with time. Okay. These people are not here. Everybody is gone. I'm the only one available. Is that okay? So when you have a decreasing speed, an increasing speed with time, the body accelerates. If you have a decreasing speed with time, the body decelerates or is retarded. So, yes, this angle is constant. So acceleration is constant. Okay, but positive. This angle too is constant. Yes, acceleration is constant or uniform, but in the opposite direction, hence deceleration. Then if you have this, if the velocity increases, but not increases or decreases, but not within equal intervals, we talk about non-uniform accelerated motion. Non-uniform accelerated motion. Can I clear this? So we have non-uniform accelerated motion. When the change in, when the velocity either increases or decreases, but not within equal intervals with time. The slope is certainly equal to the acceleration, but it will give you acceleration within a given time or period, hence instantaneous acceleration. Just as we saw for instantaneous velocity. So if you have this velocity time graph, and it's like this, this will give you, okay. So to pick, you can only determine within a certain time interval. Okay. So maybe within a time interval 1 and 2. Okay, so the slope, which will be equal to changing this delta V and changing this time. So delta V on T will give you that the velocity within this time interval, within a given time interval. Don't forget here too, when the body's velocity doesn't change, the body does not accelerate. That is why when I'm moving, when I'm running, and I'm running at constant speed, even though time continues to drain, I'm not accelerating. because they change, because I'm maintaining the same speed. The change in my speed is equal to what? 0. The initial is equal to the final. So there's no change. And when there's no change in the displacement, in the velocity of a body with time, the body does not accelerate. So that's why, Kenneth, I'm saying that they can't just take OEP and then no. It should be draw within a time interval. Maybe within this time interval and this time interval, then you draw this to determine the acceleration or the slope within. If this is another point I'm considering, draw a tangent. But if there's a point P, it has to do with within a certain, then I find, okay, the slope within that period. Then I can get a change in, okay. So the velocity here, and then within that time, and velocity within that time will give me a change for delta V and delta T. That's how it must be, right? All right, so when the motion is the other way around, yes, decreasing, but not within equal interval. We also have what? A deceleration. Okay, but this will also give us an instantaneous what? Deceleration, velocity time gamma at the time. This will also, just as this would give us instantaneous acceleration within, this will also give us instantaneous deceleration. Okay. All right. Now another graph. Don't forget this is increasing, and so this is also increasing. Okay, this is also increasing, but this in the opposite direction as this one. That's why this is positive and this is a negative. Okay. Now, so if you have this, what does it mean? And it's a velocity time graph. What does this mean? Yes. Immaculate. Your view. Simple. So when the slope, when the angle theta, the graph, theta graph makes with the time axis. T. When theta is equal to 0, it means acceleration is 0. No slope. Acceleration is 0 because A is equal to change in velocity with time. Okay. So if you pick any 2 points, don't forget there's a time interval, but simply you just T. Okay. Look at this point, maybe T1, T2. What is the velocity to this? Maybe this is X or V. Okay. So V, and the change is always final minus initial. Don't forget. Okay. What is the final? V, the same V. What is the initial? The same V. But the time interval is T2 minus T1. The numerator is 0. The denominator is this. Because there's no change, the body will never accelerate. That's why if you just pick a point P, and there's no other one to compare with, there wouldn't be acceleration. Okay. So when the angle, the graph makes with the time axis is 0, the body's acceleration is also equal to 0. So simple. Lastly, help me identify the difference between these two graphs. And open your eyes well. This pairs of graphs. And finally, so we have A, B, C, we have and what's the difference between A, Immaculate?
The first one is a uniform velocity, and the second one
Good one. So you are right, but talk about the acceleration here and then the acceleration here.
with the one.
Mhm. Once you said velocity is a uniform velocity motion, then it means the velocity is uniform or constant. And so
That's
let's come here.
and this one, the acceleration is equal. It is acceleration.
And it is
Is
so the acceleration is what? It's uniform. Or okay, meaning it's the same along the motion, the same acceleration along the motion. Okay, do you get it? Over here, because the velocity is uniform or constant, acceleration is 0, as you said. Over here, the acceleration is uniform, constant throughout the motion. Do you get it? Yeah, Kenneth, B.
The first one is constant or uniform velocity motion.
Okay.
The second one is
So you have to talk about, you are describing the graph, but you have to also talk about anything velocity and anything acceleration as well.
so the body. uh,
This is a uniform word, meaning that
the body
it's moving with constant or uniform speed throughout. What will you say about the acceleration of the body here?
Then the body has
So acceleration is zero. Let's come here. What do you see?
one. As for the second one, the body does not accelerate, but has a constant velocity.
Why doesn't the body accelerate?
This is because the at every given time the velocity remains the same.
Good. Is that okay? So zero acceleration with a constant velocity. Zero acceleration with a what? So what will you say about these two graphs? They are the same. Uniform or constant velocity. When velocity is constant or uniform, acceleration is zero. Constant or uniform velocity, acceleration is zero. So these two graphs are the same. Okay, Immaculate, the third graph,
graph shows body acceleration.
good. So stationary body. Mhm.
Many times there's no velocity.
Zero velocity. And so and once its velocity is zero, its acceleration would also be zero.
And that one, the body is not accelerating but has a constant velocity. So
They are not the same. The icing on the cake is this. I have this velocity time graph, and the motion is like this. Help me describe the motion. What is happening? Can it?
The body accelerated
Mhm.
20 seconds.
Accelerated uniformly.
And then go to a point.
Then let me also add this graph. Let me also add this graph for Immaculate. So you can it?
The body accelerated when it got there. It
Mhm.
body accelerated means from point eight. There were go to point eight.
To a set to a velocity A, B, C, D. Okay. Mhm.
Go to point it stopped accelerating, started moving with a constant velocity. You go to C and decelerated to
Use the terms decelerated.
it decelerated uniform.
Mhm. Okay, let me also come in. Can you say it in a different way?
the body spectrum moves with a constant velocity, hence accelerating. and reach to a point B where sorry, it started in acceleration. When it reached a point, it started continued with a constant velocity, meaning that the velocity that he used to reach the point B, he didn't increase it again, continued with that. So he reached point B and then started decreasing it. So he reached to B.
Let me also come in. From a body starts from rest. And when a body starts from rest, it means its initial velocity is what? 0. Accelerated uniformly within a time interval t1 to b. So a body starts from rest, accelerates uniformly, okay, within a time interval t1 to a point b. Then the velocity, okay, is maintained within a time interval from t1 to t2 to point C. Then decelerated uniformly from point C to a point D to rest within a time interval t2 to t3. It decelerates uniformly from C to D to rest, meaning at D the final velocity is what? 0. Within a time interval from t3 to t2. That's it. That's the motion here. Let's come here. What is happening?
So a body starts from point rest. A body starts rest from point.
No.
A body at rest starts accelerating.
No.
The body was
This two are not the same.
the body was moving.
A certain velocity from point A and accelerates uniformly to a point what? B within a time interval t1. Then
it moves with a constant velocity from point C to point C within the time interval T1 to T2.
good.
When it reaches the point B, it decelerates from
It decelerates uniformly.
Point C to point B, where it rests within the time interval T2.
Or using the time interval.
T2.
That's all. That's all. So this is where I draw the curtains on today's meeting. Thanks for being part of today's show. Thanks so much for your contribution, your analytical observation, and all that. Please.